Hello guys, welcome back to Infinite Insight Geometry, Lesson 5.1, the four centers. Alright, let's begin. So, we've been talking about triangles all of this time, and maybe you're asking yourself, what is the center of a triangle? Because, well, there's not really a way to measure the center of a triangle. Is it a point with the same distance from the vertices, the same distance from the angles? What geometric figures make a specific point the center of a triangle? And if you want, you can pause the video, cut out a triangle maybe, and if you want, try to figure out where would be the center of a triangle. What properties must it have to be a center of a triangle? So, turns out there's not really a correct answer to this question because there's actually multiple centers of a triangle, 4 in total, like the lesson title. These centers are all of the triangle's centers in their own way since they are made with different geometric constructions, and they are called different things other than centers. So, what are these different geometric constructions and what are these different centers? The first one that we're going to talk about, the first center, is the circumcenter. First, we had to learn what a perpendicular bisector is. A perpendicular bisector is a line that bisects another segment and is perpendicular to that segment. So let's say if you had a segment, then the perpendicular bisector of that segment is a line that bisects that segment and is perpendicular to it, meaning that it forms 90-degree angles. And since a triangle has 3 sides, has 3 segments, the circumcenter is the point where the 3 perpendicular bisectors of each of the triangle's sides meet. And you can try this out. Draw out the 3 perpendicular bisectors of a triangle, and they all will intersect at one specific point. Now, this drawing is just drawn for clarity, but point M in this drawing is not exactly the circumcenter. This figure is just a figure for clarity. This is not the actual circumcenter. There are 3 points on a triangle, and you can always make a circle that touching those 3 points. The circumcenter will always be the center of the circle touching the 3 vertices of the triangle. As you can see, point M is not the center of the circle. It is more pointed up. It's higher than the center of the circle, meaning that it's not the circumcenter of the triangle. It is actually just a random point on the triangle, because if you can see, if you have a sharp eye, you can see that the top 2 sides, not the bottom side, but the top 2 sides, those perpendicular bisectors are not perpendicular bisectors at all. They don't bisect it. They do, in fact, make a perpendicular line with the segment, but they are not bisectors, meaning that this is not the circumcenter. Now, angle bisectors is a ray that bisects an angle. We've already talked about this, and the incenter is the point where the 3 angle bisectors of each of the triangle's 3 angles meet. And as you can see, if we have 3 angles in a triangle, then we can have 3 angle bisectors, and we can make them all meet up at the incenter. And a triangle always has 3 sides, and those 3 sides are always arranged so that a circle can be made that is tangent to all 3 sides. Now, if you don't know what the word tangent means, then don't worry. We will go over that in other lessons. Just know that a tangent to a circle is a line that barely touches the circle, just at one singular point. It does not go through the circle, but just barely touches it. Think of a ball pressed up against a wall. That is a tangent to the ball. The incenter will always be the center of the circle that is tangent to all 3 sides of the triangle. So there will always be a circle that is tangent to all 3 sides of the triangle, and the incenter is the center of that circle. What is a median? A median is a segment that bisects one of the triangle sides with the other endpoint at the other vertex. And the centroid is the point where all of a triangle's medians meet. So there are three in total because there are three sides. You get a point and bisect one of the sides and then connect it to the other vertex of the triangle. That would be a median. And the centroid is where all three of those triangles' medians meet. The centroid is very useful in engineering since the centroid is always inside the triangle. The centroid is the center of the balance for every triangle. So let's say if you cut out a wooden or paper triangle, if you want to do that right now, the centroid is where you would put your finger for it to stay balanced. So if you had a triangle, you have the centroid, you put your finger on it, and if you balance it just right, it'll stay upright on your finger. And lastly, we have altitudes. An altitude is a segment that passes through a side of a triangle perpendicularly and the other point of the triangle. And the orthocenter is the point where the three altitudes of the triangle meet. Now, if you don't know anything about altitudes, that's okay, because we never really talked about this before. But just think about it. If you have a side and you have another point, then you can always make a perpendicular line starting from that point down to the line, making it so that the lines are perpendicular. And this will always be true for all triangles, meaning that all triangles have three altitudes, and the orthocenter is the point where all three altitudes meet. The orthocenter is special because it doesn't necessarily have to be inside the triangle. Acute triangles have it inside, obtuse triangles have it outside, and right triangles are special because they have it right on the hypotenuse. Orthocenters are very, very special. So this is a chart that I made. You can see on the very left, you have the types of centers: the circumcenter, the incenter, the centroid, and the orthocenter. The geometric constructions, the perpendicular bisectors, angle bisectors, medians, and altitudes, they're all types of lines or rays or segments that cross at a specific point that we call the centers. Now, we've also have a lot of special properties that we haven't already discussed, such as the circumcenter is equidistant from its vertices, and the incenter is equidistant from the sides. The centroids divide the medians into a 2-to-1 ratio, meaning that the centroid is exactly 2/3 the way from the point to the line. And the orthocenter doesn't really have to be inside a triangle. Now, the incenter and the centroid are always inside the triangle, but the circumcenter and the orthocenter depends on the triangle. Depends whether it's a right triangle, depends on whether it's acute or obtuse. It really depends. And these four centers are very important because they make us show how we can use these centers in other contexts, such as the next lesson that we will be talking about, Euler's line. Euler's line will be a line that passes through multiple of these centers, and we'll go through that next time on Infinite Insight Geometry. And that'll be all for today's lesson. If you liked the video, please like and subscribe. I have my email down below if you have any questions, and I will see you all next time.